let's take the case of a rod which is leaning against a wall. Length of this rod is L, and this end A is being pulled in the horizontal direction with velocity V, and end B will obviously be moving down. All the time these two ends A and B, they are not losing contact with these surfaces. They are not losing contact with these surfaces. We are asked if the velocity of this is V, length is L, at this instant the angle is theta, what is the velocity of end B? So one way of doing it, we draw this right angle triangle where this length is, where this distance is y, and we take this distance as x. This is theta and this is L. So at this instant obviously we can use the Pythagoras theorem, that is x square plus y square is equal to L square. L is always constant, so this square plus this square is always going to be this L square. So if we differentiate it with respect to time, so 2x dx by dt plus 2y dy by dt, that comes out to be equal to 0. So this means 2 and 2, that is obviously that can be cancelled, taken out and cancelled. So x dx by dt is equal to minus y dy by dt. So it comes out to minus. It means that is only one is increasing, the other is decreasing. The other value is decreasing. If value of x is increasing, so the value of y is decreasing. So this we know, that is dx by dt. What it stands for? Dx by dt stands for, that is how this x is changing with time. That is rate of change of x, dx by dt. That stands for nothing but velocity in this direction. Similarly, dy by dt stands for, that is how this y is changing with respect to time. That is dy by dt stands for Vb only. That is dy by dt stands for velocity of this end only. That is, we call this as Vb. So when we put the values of dx by dt as V and dy by dt as Vb in this equation, so this comes out to be x into V, dx by dt is obviously given as V only, is equal to y into dy by dt. Dy by dt we have said that is equal to Vb. So Vb comes out to be x into V by y. Now in this right angle triangle, y by x is equal to tan theta. We know that tan theta is equal to y by x, or cot theta is 1 by tan theta, that is x by y. So Vb comes out to be, so it means that at this instant, if the end A is moving in this direction with the horizontal velocity V, then this end shall be moving with velocity Vb, that is V cot theta, in the vertical downward direction. This is one way. The other way of doing it, that is the relative velocity along the line joining these two ends should be equal to 0, because this is a rigid rod. It means that is the distance between these 2 points B and A along this is always going to be L only. So it means if we find the relative velocity of this point and this point along this axis, it should be equal to 0, because these points A and B, they are stationary along this line. This distance is always going to remain same. So if we take, that is velocity is in this direction, at this instant this angle is theta. Suppose we have taken this V over here and we have taken Vb over here. So if this is theta, so this is going to be 90 minus theta. So this is going to be 90 minus theta. So what are the velocities of these points along this axis? This is V, this is theta. So velocity of end A along this line is V cos theta. Let's remove this. So this is velocity of this end A along this rod is V cos theta. Similarly, V2 is in this direction. So velocity of this end B along this way is this way. Vb is going to be Vb cos 90 minus theta. So this is going to be the velocity. Cos 90 minus theta is sin theta. So this way velocity component is Vb sin theta. The relative velocity of B and A along this line is equal to 0. So that's why V cos theta should be equal to Vb sin theta. Sin theta goes over here. So V cot theta is equal to Vb. We get the same answer. We can also do this question by using the concept of instantaneous axis of rotation. At this instant, this end is moving with velocity V in this direction. So obviously, when this is going in this direction, this is going in this direction, we can assume the whole rod to be rotating about some instantaneous rotation. This is in angular velocity, this is going to have some angular velocity. How to find the acceleration? We know that is if this is moving in this direction, the acceleration will be somewhere on the line perpendicular to this. Similarly, when this is moving in this direction, the instantaneous acceleration will be in line perpendicular to this. So it means where these two lines they cut, that is the instantaneous acceleration. And about this whole omega for the whole body, it has to remain same. That is, if we take this as R1 and this as R2, it means V is equal to R omega or omega is equal to V by R. That should remain same. It means omega is equal to V, this is V, by R1 should be equal to VB upon R2. V by R, this is moving in a circle of radius R2, and at this instant this is moving in circle of radius R1. Omega is same for the whole body, so it means omega is equal to V by R1 should be equal to VB by R2. Now what is R1 and R2? If this length is L, so from here to here is L, this angle is theta, so this is going to be L cos theta. So this is also going to be L cos theta. So it means R2 is equal to L cos theta. And what is R1? If this is L cos theta, so this is also L sin theta. So this is also L sin theta. So R1 is equal to what? L sin theta. We put it over here. So it means V by R1. R1 is what? L sin theta. L sin theta is equal to VB upon R2. R2 is what? L cos theta. L cos theta. So VB, L and L they get cancelled. So it is V into cot theta. Once again we get the same answer. But so by all the three methods we get the same answer.